All right, so today we're going to go ahead and we'll be working on these learning targets, make and interpret dot plots. We've actually had some experience with that with the pilot activity. Stem plots, we might not get to that today. We're going to work on this though quite a bit, describing the overall pattern, shape, center, and spread of a distribution, and identify any major departures from the pattern called an outlier. Okay, and then we'll also get to some specific terms for shapes of a distribution. Skewed is a phrase we'll use, and roughly symmetric is a word we'll use. Okay. Okay, so I want you to continue to read through page 25 and then all the way over to 26 as well as they start discussing how we describe shape, center, spread, and outliers. Okay, go ahead and take a couple minutes to do that. You might not be done reading yet, but let me talk about this real quick and make a little more sense when you are reading their solutions. This is always a free response question on the AP Stats almost every single year. They say, describe the distribution. Okay, so we got to make sure we know how to do that. Shape, center, and spread. You should always address those three things. And then if you see any type of departure from the distribution, also called an outlier. Okay. All right, good way to remember this is a little acronym. There are a lot of acronyms throughout the year in AP Stats. CUS is one of them. Okay, you see a distribution, I'll tell you to cuss it out. Maybe not literally, but figuratively, you need to go through these things. So C is going to stand for center. Choose an appropriate measure of center for the data. All right, in 1.3, we'll talk about which one's most appropriate. For now, we'll probably just use median. That's what I put right there. Use median for now until we discuss how to figure out the best center. Okay, unusual. If the distribution includes values that appear to stand out from the overall pattern of the distribution, then we refer to these as unusual or outliers. Eventually, we're going to have an equation for that. For now, you just kind of use your eyes and your intuition to figure it out. So just use your judgment when determining this. We'll have an equation for this later. Okay. Shape. We're really close to getting to some definitions on this, talking about skewed left or skewed right. Symmetric. Normal distribution is until chapter 2, but we'll talk about uniform as well. Okay. And spread. Just think about how far spread out the data is. Okay. Is it from, well, we'll look at some specifically here in a minute. But for the most part, we're just going to use range in this section until we get to some of these other terms. Okay. Standard deviation will eventually be the most common measure of spread, but we're not ready for that yet. So we'll just say that it ranges from 5 to 20 or something like that. Okay, so like I said, go ahead and read through the example on the bottom of 26 and 27. Then we'll go ahead and take a look at how they did this, and then move on to describing shape. Okay, so if it appears symmetric, if you want a little visual aid on it, it might look something like this compared to the others that are skewed. But it's just roughly symmetric. It doesn't always have to be perfectly symmetric. Very few distributions with raw data are perfectly symmetric. So a lot of times we'll say roughly symmetric. Okay. So if the right and left sides of the graph are approximately mirror images of each other, we say it's a symmetric distribution or roughly symmetric. Okay, and for this one, skewed to the right, if the right side of the graph is much longer than the left side, we call that skewed right, or positively skewed is another phrase for that. So if the right side of the graph is much longer than the left side. So it's usually where the tail extends to. So it's considered skewed right when you're kind of drawing the distribution if the tail of the curve extends right. Okay, just the opposite for skewed lefts. And sometimes it might be like a dot plot here, and we're trying to kind of figure out exactly what the shape looks like. So the dot plot might look like this underneath, and then it looks like it's roughly skewed left. The tail extends that way. So if the left side of the graph is much longer than the right side. Okay, also called negatively skewed, because it's going in the negative direction, right? Because these dot plots and the number, this is based on a number line format down here. The scale will be, so that's why that's called negatively skewed. All right. That's exactly what they're saying there, what I just said. I want you to add a uniform distribution here. A uniform distribution is going to be kind of about the same across, all the way across. So for example, if I were to have a hat with numbers 1 through 10 in the hat, and we randomly pick a number, we record it, and then we put it back in, shake it up, and draw again, well, the likelihood of drawing all these numbers is going to be pretty uniform, or equally likely, right? So in the long run, if I'm recording this data, it's going to be pretty uniform. Am I going to have some maybe a little lower, some a little higher? Sure. But if I do it over and over and over again, it's going to be a uniform distribution. Okay? Straight across. Okay. All right. You see the flow of a lot of this class will be a little bit of everything, because I know students learn linguistically, visually, auditory, things like that. So that's why I give you visual aids, to have you listen to me and discuss. I have you read. I'm trying to hit all these different learning styles. Okay. So I'm not just trying to waste your time or fill in time. I'm trying to get for a deep understanding of all this. So back to some reading here. Go to page 28 and 29 while filling in the definitions below. And then when you're ready, I want you to complete the check your understanding on page 29 using the space provided in the notes. You're going to try to basically cuss out a distribution, but they walk you through it. Okay, I'll give you about 5 minutes to do that task. Go ahead. What you've learned before, that mode is what occurs most often, right? So a unimodal distribution that has a single peak, it's pretty easy to tell what that is. The mode on this distribution is the number 7 occurred most often. And it has a single peak, okay? Bimodal, if I'm just looking at data, not the distribution, does mean there's kind of a tie, right? For, let's just say I took a survey and the number of siblings of a little group of people, and I get these responses are the same for 0 and 2. That's also called bimodal, but when we're looking at a distribution, it's usually referring to two different clusters that have two different peaks. They don't actually have to be a tie. Like this one definitely is a tie with the outcome of 3. Okay, but this distribution is still considered bimodal, even though this mode overall is the winner, but there's two different clusters here. Duration of Old Faithful's eruptions. Some have this cluster of being longer, and then some have these clusters of being much shorter. Okay, so bimodal means there's two different peaks when we're talking about distributions. Yeah, what you got?
If there's like a peak at 1 and 2, is it still, like they're right next to each other, is that still bimodal?
It's still going to be, yeah, it's going to one peak. Yeah. So if it's there, you're saying if like these two are tied, that this was all the way up here, that's still going to be kind of one peak. That's a good question. Okay. And then if there's a third cluster, maybe in the middle here, I don't know if you caught on to that, but they could call it trimodal, but it's just not common. At that point, we're just going to call it multimodal. Okay. They're pretty rare. We don't see distributions like that very often, but that's how we handle that. Okay. Any other questions on that? So bimodal, two distinct peaks or two different clusters, single peak, more than 3 peaks. Okay. All right. I don't think I gave you enough time to do the check your understanding, so go ahead and do that. Okay, here's your feedback. Distribution is right skewed and unimodal, single peaked. Okay, if we see two different clusters, we'll say bimodal. Remember, where does the You might want to do this. You don't have to, but I kind of just roughly did this little mound or sketch above it to help me see where the tail extends. Extending to the right, we got to say it's skewed to the right or positively skewed. Any questions on one? Okay, on to center of the distribution. So if we go through, how many are on here? How many data points? Anybody?
26.
26. Okay. So it's even number, right? So we got to average the 13 and 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Did I count that right? 2, 5, 6, 7, 8, 9, 10, 11. Yep. So the 13th and 14th definitely have to be an average of 1 and 1, right? If we listed this data set out, it would have been 0, 0 is an outcome, 0 is an outcome, and then I got a bunch of these ones, right? Going on for quite a while. So the 13th and 14th data points are both 1 anyways. So the median is 1. I have 1 and 2 or 1.5. Hold on, maybe we're off on data points here. Let me double count this. So check that. 28 data points. So it's between the 14th and 15th. So this is 14 points here. I got 14 over here. So it's between 1 and 2. All right. So the median is between 1 and 2, or if you put 1.5, that would probably be the best answer. Okay. All right. The spread, simply put, just talk about the range of values for now. Okay. So the number of siblings varies from 0 to 6. All right, and we had a gap here, right? These are much bigger families. It's kind of a departure from the normal outcome, because normally, typically, we'd expect it to be 0 to 3. That's the typical outcome. Gap 5 and 6. So there are 2 potential outliers. We want to be safe because we don't have the formula yet. You can throw out the word potential. If it looks obvious that it's an outlier, you can just call it an outlier. Call it what it is. Yeah, 5 and 6 siblings. Okay, any other questions on 1 through 4? Okay, let's move on to comparing distributions. 1.2.3. All right, comparing distributions is very common. So go ahead and read that and read page 30 along with this AP exam tip. They talk about some real important things that is expected whenever you do a free response problem when you compare 2 distributions side by side, as you're going to see on page 30. It's not in your notes, but if you look at this example here, it's a good example of comparing 2 distributions like that. Okay, I'll give you a couple minutes to read that example. Go ahead. All right, make sure you are obvious when you compare. You have a problem on your chapter 1 test where I'm going to ask you to compare distributions. And if you don't say words like this and comparing them, then I have to mark you down because they would too. And I got to keep you guys accountable to that. All right. So we'll see it on center right away. When they're comparing these 2, household sizes for the South African students tended to be larger. Here we go. There's the comparative statement. Than for the UK students. And then when possible, which it is possible here, actually get the numbers. The midpoints or medians are 6 versus 4. Okay, got to compare them. The shape, we just talk about both of them separately. We should see a skewed right distribution here, and then we should see one that's kind of roughly symmetric. And unimodal for both. Okay, you guys read it. Finished with spread outliers. They organize a little bit differently. A lot of students like to just go in the order of Cuss. It doesn't matter as long as all 4 are addressed. So you can start with center, unusual, and then spread shape last. Okay. Okay, well, stem plots, basic ones are real easy, but then they get into splitting them and back to back. So I'm going to save those for tomorrow. So let's wrap it up right here. I'm going to let you work on your OTI the last 15 minutes here, okay?